One of the most important and versatile functions in mathematics is the squaring function, y equals x squared. It's a very important function in the process of modeling things mathematically. Let's look at how we get a table for y equals x squared. Now this is familiar to everybody. If x is -3, then when we square it to get y, you square -3, you're going to get 9. You square -2, you get 4, and so forth. You square 3, you get 9. We notice that there's a symmetry here about 0. The numbers that we get this way going from 0, the y values, are the same as the y values we get going this way from 0. And that behavior is reflected in this somewhat crude graph of y equals x squared. Now what does the y equals x squared function have to do with the mathematical model, or the process of modeling mathematically, the flow versus depth? Well, we notice that the flow versus depth function decreases more and more slowly. If we look at this part of the graph of the y equals x squared function, it also decreases more and more slowly down to some down to some low value called the vertex. We should know that the shape of this graph is a parabola. It's symmetric about the y-axis because of the symmetry that we see here. Now if we take this graph and just isolate this part of it, this looks a lot like the shape of the depth versus time function. Of course, it's in the wrong place. It's on the wrong side of the vertical axis, but there's no reason we couldn't just pick this thing up and move it over. And if we did that, we might have something like this. We might shift the graph over and only worry about the part from here to here. We don't care about the rest of the parabola. It goes up here forever and it goes around here and comes back up, but we don't care about that. As far as this model is concerned, it starts at depth 100 and ends down here. Now, of course, the y equals x squared function has to be stretched out a little bit because the original function between here and here, the change in the horizontal coordinate, the change in what we would think of maybe as the time, is only 3 units, and it has to be 71. So we have to stretch it out this way. And we also have to stretch it this way because between the part of the graph that we saw before was nowhere near 100. It was only up to 9. So we're going to have to stretch it this way. But when we do, we will get a function of this form. Anytime you shift and stretch y equals x squared function, you get a quadratic function of this form, and any quadratic function can be gotten by stretching and shifting some y equals x squared function in some way.